Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the subject Mathematics 2, and chapter is first order ordinary differential equations, and today's topic is linear differential equation. This method is also you already learned in your school level. Just we have to revise and just summarize this method. So let's start with the method. The differential equation of the form dy by dx plus p of x into y is equal to q of x. This is called linear differential equation in y, where this p of x and q of x are function of x only, or might be they are constant. Okay, so this differential equation is called linear differential equation in y whenever we have this dy by dx and this y, dy by dx, this y, and other than that all the terms, all the functions are function of x only. There is only identification is dy by dx and only y raised to 1, only y raised to 1. Other than that each and every term is of x. Okay, then we can find if. Okay, and this equation 1 also known as Leibniz linear equation, as I told, and if is given by e raised to this p of x dx. After finding this if, we have the solution is given by y into if, value of if, y as it is, integration q of x, that means this right hand side, and into if multiply with these two, and dx with respect to x integration plus c. Similar way, same we have another form of linear differential equation. In that, just we interchange x and y. That means the differential equation of the form dx by dy. When we have dx by dy, then x is the only variable. X is with power 1. Other than that, we have p of y and q of y. That means p and q are function of y only, or might be constant. Okay. So this is also linear differential equation in x, okay, in x of first order. Now if this, then same as is also known as Leibniz linear equation, and we can find if by using this p of y, that means e raised to integration p of y dy. And after getting if, this general solution is given by x into if, because we have this x, that means this LDE linear differential equation in x, that's why we have to use here x into if is equal to integration q of y, this into if dy, that means integrate with respect to y. Okay, so we have two type of linear differential equation, two varieties are there. Okay, so let's understand with uh, one or two example. So here we have this question is given, solve x square y dash plus 3x square y is equal to 1 by x. You can see that we have y dash, that means dy by dx, and y is the only simple y raised to 1. So this is our first type. Okay, so we can write y dash as a dy by dx. Now as we know that we have compulsory this form dy by dx plus p of x y is equal to q of x. That means no any term should be multiplied with this here. Okay, so we have to remove this. So we have to remove x square. So just divide by x square. Okay, each and every term. So divide equation 1 by x cube. Sorry, x square nahi x cube. So x cube cancel out. So divide by dx. Here we have x cube. So by cancelling this, we have x, and here 1 by x cube, then x is to 4. Now this is your p of x. This is your q of x, because if we compare this equation with this equation, so compare with dy by dx plus py is equal to q. So p is equal to 3 by x and q is equal to 1 by x is to 4. Now what? Now after getting this p and q, just we will find if, integrating factor. That means e raised to integration p dx. Now what is p? So we have p is 3 by x. So 3 as it is, and integration of 1 by x dx is ln x, that means log x. So ln x, now by rule of logarithm, we will take 3 on the power, so e raised to ln x cube, and as I told, e raised to log x gives us x. So we have e raised to log x cube gives us x cube. This is our IF. After IF, we know what we have to do. Just we have to find the general solution. That means y into IF is equal to integration q into IF dx plus c. Why we just put y, and why we use this formula? Because we have original question is compare with dy by dx plus py is equal to q. That's why. Okay, so y as it is, if is x cube, q is 1 by x raised to 4, we already find, and if is x cube. Now y x cube is as it is. By cancelling this, we have remaining 1 by x, and integration of 1 by x is log x and plus c. Okay, so this is our final answer, which is our general solution. Finish. If you want to remove this log, so you can take, instead of c, log c, and by taking this together by using logarithm rule, and by taking anti-log, you can remove log also. Okay, but if you wish to live here, then you can also stop here. Okay, similar way we have another example. Solve y log y dx plus x minus log y dy is equal to 0. First we will find out that form particular, or you can see, sir, it is m dx and dy, then check if it is exact, then you can solve. Otherwise you have to solve by this method. Okay, so we'll take this term on the right hand side, so this become minus. Now if we find dy by dx, this term on this side and this side, but here you can observe that each and every term is of y, only one x. Now I told, if we have dy by dx plus p of x y is equal to q of x, when we will use this, and when we will use this, just I am clarifying with you. Whenever in equation you have only one power of y, that means y raised to 1 is only term and other is dy by dx, then you have to use this. Now when we have x raised to 1, that means x is only and dx by dy, then we have to convert in this form. So here you can see x is the single x, we have only x raised to 1, other than this x raised to 1 no any term with x, and this is our dy by dx. So now we have to convert this into this form. For that, dy by dx is not considered, we will find dx by dy. So we'll just uh, reciprocate this term. So dx by dy becomes log y minus x upon y log y. Now we can divide this term with log y and divide with x both. So we have 1 by y and x upon this. Now to make this x term with inside, that means dx by dy plus px. So we'll take this term on the left hand side. So this becomes our equation like this. Okay, and this is our p of y, this is our q of y. So we'll compare this with our dx by dy plus px is equal to q. So we have p and q. This is our q, this is our p. X is as it is. So after getting p and q, we will find if. Now what is the if for this method? So we have if is equal to e raised to integral p dy, because this is in the term of y. So we will put value of p. Now by putting the value of p, how we can integrate this? So we can take y to the numerator. So we have 1 by y and log y as it is. So we can use this formula. Function is in denominator, differentiation of function is numerator, so we can use log of this. Okay, this is our formula. So log y is our function, differentiation is in the numerator, so we have log of log y. Now we know that, as I told, simple logic is what? So as I told, e raised to log of anything is anything only. So we have e raised to log of this log y, so we have this become 1, so we have this log y. This is our I. Now we have this form, dx by dy plus p to x is equal to q. So for this we have solution is x into if, no, is equal to integration q into if. D, what dx or dy? So it is dy. Okay, because q is also in the form of y and if is also in the form of y. plus, so we will use this solution. So the general solution is given by this formula. X as it is, if value of if is log y. Same way, this is our q, value of if. Now here, what is the formula? So to find the integration of this, we have to use this formula: f of x whole raised to n into f dash of x dx. Function with power, and differentiation of function is in the multiplication. Differentiation of function only, not power included. So here this raised to 1, this is power. Differentiation of log y is 1 by y. So we can use this formula. That means 1 power increase, and that power is in the denominator. So we'll increase this power. So x log y as it is will increase. So log y raised to 2 by 2. And this is cancelled out. F dash x is removed, okay, from the answer. Plus, and this is our final. This is our final answer. This is our general solution. No need to simplify. Okay. So how we identify each and every different differential equation that you should know, okay, by understanding each and every example. So first of all, we have so many methods, okay, till now we have 7 methods. In non-exact we have 6 methods differently, okay. So uh, again I am just telling, try to solve each and every example. If and you will understand quickly that how which differential equation, that given differential equation is which form, is variable separable or reduced to variable separable or homogeneous or non-homogeneous or exact or non-exact. In non-exact, which method can be applicable, or it is a linear or it is in Bernoulli. That is our next lecture. So again I am just telling, please try to solve this each and every DIYs, and if you have doubt you can contact me, or we can solve your doubt in Zoom lecture also. So thank you for today's lecture. We will see you soon with next lecture. Thank you.